Hello and good day, geometry. Going over 62 and 63 today, talking about the measures of inscribed angles and inscribed polygons, and then various angles that can be created inside and outside of circles. But we start with an inscribed angle. And an inscribed angle, so in 60, I believe it was, we talked about central angles and the relationship of an angle with its vertex at the center of a circle. Its measure is equal to the arc that it creates. Well, you can also have what's called an inscribed angle, which would be an angle with the vertex on the circle instead of in the center of the circle. So an inscribed angle is an angle with its vertex on the circle, and then its sides extend to the other side of the circle. And the relationship is, let's see, it's an angle with its vertex on the circle, and its measure is half of the arc it creates. An inscribed angle is an angle with its vertex on the circle, and its measure is half of the arc that it creates. So a central angle, its measure is equal to the arc that it creates. You move that vertex back a little bit so it's on the circle, and the angle measure is half the arc. So if I tell you that the measure of the arc is, it looks like about 80 degrees, what's the measure of the angle? 40 degrees. Okay? Its measure is half of the arc that it creates. Right? Which is basically Theorem 10.7, the measure of an inscribed angle. I guess I could have made that picture a little bit larger down here, but go ahead and draw your circle. Okay, inscribed angle, you've got it on the circle. Goes across like that. If the angle measure is 85 degrees, what's the measure of the arc? I kind of switched it up on you. Yeah, it's going to be 170, okay? The measure of the angle is half the measure of the arc. So if you're given the arc, you divide by 2 to get the angle. If you're given the angle, you would double it to get the arc, right? But that's the relationship there. Boring you already? It's been 3 minutes. I promised 2:30, but okay, there we go. All right. Theorem 10.8 has to do with what happens when you have congruent inscribed angles. So I'm going to ask you to draw another circle. And if you have two inscribed angles, let's have one going like this and one going like that. And we'll draw a second inscribed angle. I'll do this in red so you can tell the difference here. One going like this and one going like that. What do you think is true about the measures of those angles? Of the two inscribed angles that we have here. One's in green, one's in red. What do you suppose is true about the measure of those angles? Just based on what we already know about circles or what you can maybe surmise. Julia? Okay, maybe. Oh, right, yeah, right here in the middle. Maybe where they bisect or where they intersect makes a 90-degree angle. Not in this case, but looks like. I mean, I say maybe in this case, but not always. Elise? Vertical angles do exist at that point of intersection there, but I'm more focused on this angle and this angle there are two inscribed angles that. Here's a hint, create the same arc, right? Both the green angle and the red angle create the same arc on the circle. So what do you suppose is true about the angles themselves? Linnea?
If they create the same arc, then they'd have to be half of the arc. They both be the same angle.
Right. The relationship of the angles to the arc is half, just like in our first one here. But the relationship to them to each other is their congruent angles. So two inscribed angles that create the same arc are congruent. Okay, two inscribed angles that create the same arc are congruent. And as Linnea said, also would be half the measure of that arc that they create. So if you're told that this angle is looks to be about 45 degrees, then you would know that the other inscribed angle is also 45 degrees because both of them make the same arc, which we would know to be 90 degrees. Okay. Questions on inscribed angles? No? Very well. An inscribed polygon would be a polygon inscribed in a circle, meaning that it is a polygon with its vertices on the circle. You've seen a lot of these in your shaded area questions, you know, a lot of shapes inside of shapes. Those are all inscribed polygons because they had their vertices on the edge of the triangle or the outside of the circle or whatever. And the two specific types of polygons we're going to talk about, because we've had them earlier in the year, is a triangle and a quadrilateral. And our theorem for a triangle, okay, my circle game is on point today. Look at that. Just, I mean, it's not perfect, but for freehand, no one's going to agree with me? Sure. No one's going to? Thank you. Yeah. Thank you. Okay. What Theorem 10.9 says, that if you have an inscribed polygon and one of those, or an inscribed triangle, and one of the sides of the triangle is the diameter, then you are guaranteed to have a right triangle. Okay. So for an inscribed triangle, if one side of an inscribed triangle is the diameter, the triangle is a right triangle. Okay. If one side of an inscribed triangle is the diameter, the triangle has to be a right triangle. Which you could flip the other way and say that if you've got a triangle and a circle that you know is a right triangle, you know that the hypotenuse would be the diameter. Okay. For a quadrilateral inside of a circle, so again, draw. Oof. Who threw me off? Alan? Thank you for that. If you have a circle with a quadrilateral, so four-sided shape, well, 1, 2, another point there, point over here, kind of a, not quite a rectangle, but, okay. Four-sided shape inscribed in a circle. Theorem 10.10 says the opposite angles of an inscribed quadrilateral are supplementary. The opposite angles of an inscribed quadrilateral are supplementary. So, if you know that this is 80 degrees, what can you tell me about the measure of the angle opposite that? Gabby? 100 degrees, okay? Remember that word supplementary means add to 180. And so the opposite angles of an inscribed quadrilateral are supplementary. All right, now we get to practice this. And here's the deal with how this unit is going to shake out. You're not going to have any book homework. Everything that you need is going to be on the lesson page itself. So if you look at something and you're not quite sure kind of how to do it, look back at the pictures that we drew, look back at the theorems from this page, and that's what does this look like? You know, where have I seen something similar to this before? So this first one here, we've got two inscribed angles, and we're looking for the measure of arc QT. Raise your hand if you can tell me the measure of arc QT. Emily, 100. It is the arc created by that 50-degree inscribed angle, angle R. So we double the 50 to get 100. RTS. RTS, meaning we're going all the way from R through point T and all the way around to S. Remember that, angle RTS. Whoops. Angle RTS. So this angle right there. What's that measure? Elise? It wouldn't be 12. Half of 48? 24. Yeah. 24. Because the arc that creates arc RS is 48. The next one. Well, we have two inscribed angles. We actually have several inscribed angles here that creates common arcs. So angle RTS, which is this angle right here, RTS, we notice that RTS creates the arc RS, which is the same arc created by angle RUS. And so back up in our theorem where we had a situation similar to this before, what can we say about angle RTS? What will it be? Julia? 31 degrees. Right? Congruent to the other inscribed angle because they create the same arc. The next one, arc RUS. Okay, since it is a three-lettered arc, it means it's the long way around from R to S, from point R through point U, all the way up to S. Whew. Yikes. Game plan for this one. What do you think? Julia? Sure. We can double 31 to find the measure of arc RS, right? Arc RS is 62, and that helps us because, well, the arc we want is just the rest of the circle, right? If we know that that piece is 62, what's the rest of it? 298. What a gentleman. Which is correct. Okay, because 298 plus 62 equals 360. The last one here, we have an inscribed quadrilateral. So we look at our example up above and we say, oh, okay, the angles, the opposite angles of an inscribed quadrilateral are supplementary. Turns out I don't ask you for any angles though, so that's a little bit interesting. I start by asking you for arc KJM, which is from point K through point J all the way over to M. Whew. With no angles given and no other arcs given, how do you tackle this one, Emily? 6b equals 180. How does that help us?
Because they're like supplementary.
So you are correct. 6b does equal 180 because if we add these two opposite angles, 4b and 2b, we get 6b. And since they're supplementary, that means they equal 180. But we don't really need 2b or 6b to find the arc KJM. Arc KJM is formed by this angle here. So really, we want to figure out what angle L is, right? Elise? 2a plus 2a, or 4a, equals 180, which means that a is equal to what? 45. And if A is 45, what's the measure of angle L? 90. And if that's 90, what's the measure of the arc that angle L creates? Going back to inscribed angles in general here. If that angle measures 90, what's the measure of the arc that it creates? 180. Okay? It's all coming together here. All coming together. Arc JL now. Here's where we might want to use that 2B and or not 2B. Yes, 2B and 6B. Get it? Mrs. Chalmers would have gotten it. Okay. Arc JL, which is created by that angle of 2B. We already have the equation 6B equals 180, which means that B is equal to 30. And if B is equal to 30, then two of them is equal to 60, or angle M. And if angle M is 60, then the arc that it creates, which is arc JL, is what measure? 120. Double it. Okay? And the last one is LMJ, which is the long way around the circle from L to J. If we already know that arc JL is 120, what does that leave for LMJ? 360 minus 120, 240. Right? Which, if we know that B is 30, and we multiply 4 times B, 4 times 30, that's 120. We double that to get the arc measure that this inscribed angle creates, and we get a 240 that way as well. So no matter how we slice it, 240 is the arc measure. Questions on this objective? Okay. Onward and forward we go. Whoops, I went up. We got this. Don't even worry about it. No, we have 21 minutes left. 2:30. Let's go. All right. So 63 deals with how you can solve for angles that occur either inside or outside the triangle that aren't central angles and aren't inscribed angles. So their vertex is not in the center. It's not on the circle. It's either someplace else inside the circle or on the outside. And there are basically 3 situations that can exist. The first one, type 1, is an angle with the vertex at a point of tangency. So if we remember what a tangent line is, ooh, that's bad. It's a line that passes through the circle in just one spot, right? And if that one spot is the vertex of an angle, so the vertex of the angle is on the circle, we have the measure of angle 1 and the measure of angle 2 there. And I'm going to put some letters in here so we can use them to help guide us here. All right, so we have a tangent line and a point that is on that tangent line, creating 2 angles. Really, this is similar to an inscribed angle. So the measure of angle 1 is going to be 1/2 the measure of arc AB, just like an inscribed angle would be. It's a point on the circle. Only one of its sides passes through the circle, whereas an inscribed angle, it's both the sides kind of go through the circle, but being a tangent line, only one angle does, but its measure still follows that same rule of 1/2 of the arc. The measure of angle 2, same thing. It's going to be 1/2 the measure of, in this case, the major arc, ACB, that it creates. So this one follows an inscribed angle most closely, and that's 1/2 the measure of the arc. But the difference from an inscribed angle is that it only has one of its sides passing through the circle. Okay? And so on the next page, if you flip over and you see a whole bunch of diagrams that you could do for homework, when you see one that has a tangent line, you know to look at this example. And these are the formulas that you need. Okay? Those are the formulas that should go on a help sheet, along with this picture if you want to draw that as well. The next type is an angle that occurs inside of a circle. See if I can get both these on here. That's perfect. Okay. So angles that intersect inside a circle. So here we've got our circle, and this is going to occur when you have two chords that intersect. So maybe one going like this and one going like that. Right? Our angle that's formed here, our point of intersection, is not the center of the circle, so it's not a central angle. It's not on the circle, so it's not an inscribed angle. So we have a different relationship that exists here. And I'm going to mark this AB and points CD, and we'll mark this angle 1, and we'll mark this different color, angle 2. Okay? And someone said vertical angles before when we had a different diagram here. Ooh, vertical angles. This one is all about the vertical angles because the measure of angle 1 is going to be equal to half the sum of the arc that it and its vertical angle create. So what arc does angle 1 create? It creates arc AB. What arc does its vertical angle create? The one exactly across from it. It creates arc CD. And so the measure of angle 1 is going to be half the sum of the arc that it and its vertical angle create. So if AB is 30 and CD is 50, the measure of angle 1 would be equal to half the sum of AB plus the arc measure its vertical angle creates, 50. The measure of angle 1 would equal 40. Okay? Does that make sense? Right? So then for angle 2, it's kind of the same thing here. Angle 2 is equal to half the sum of the arc that it and its vertical angle create. So angle 2 itself creates arc BD, and its vertical angle creates arc AC. And so the measure of angle 2 is equal to half of that sum. And really, we can figure out the measure of angle 2 right now without any arcs labeled having to do with angle 2, BD or AC. Tell me how. Well, if we know that the arcs associated with angle 1, AB and CD equal 80, how many degrees are left for the other two arcs, AC and BD combined? If 80 degrees of the circle is already spoken for, how many degrees are left for the other two arcs total? Julia? 200. Yeah, 280, sorry. 280, right? 360 minus 80 is 280, okay? So if the sum of those arcs is 280, which it has to be if those are the only two arcs left and there's 280 degrees left between them, what's the measure of angle 2? If we know that BD plus AC has to equal 280, what's the measure of angle 2? 140, which makes perfect sense Because if angle 1 is 40 degrees, why would angle 2 have to be 140 degrees? Elise? They're supplementary. They make a line, right? And supplementary angles have to make the line has to make angles that add to be 180 degrees. So there's lots of different tools you can use here to get the values that you want. So on the next page, when you see a picture of two chords intersecting in a circle, you're going to look back to this and say, okay, what's my formula? The angle I want is equal to half the sum of the arc it and its vertical angle creates. Type 3 is angles that intersect outside of a circle. And there are actually 3 possible ways for an angle to be created outside of a circle. So we're going to draw 3 different pictures here. Okay? 3 more chances at glorious circles. Oof, that wasn't glorious a circle. Okay? The first situation is if you have a tangent and a secant. Okay? So a tangent that intersects the circle in just one place, or I suppose continues on here, okay? And a secant. And we're going to call this angle angle 1. The second scenario is if you have a secant and a secant. And again, we'll call this angle outside the circle angle 1. Anyone guess what the third type is? Linnea? A tangent and a tangent. So option 3, a tangent, just clip that circle in one spot there, and a tangent, there we go, and we'll call that angle 1. So our angle 1 is always the angle created outside the circle by either a tangent and a secant and a secant, or a tangent and a tangent. And the nice part about this is that they all have the same formula. Thank goodness, right? And the reason why they all have the same formula is because they all create the same thing. All 3 of these create a small arc and a big arc. The small arc is the arc created closest to the vertex. The big arc is the arc created on the other side of the circle, after that point of intersection. And for all 3 situations, the measure of angle 1 is equal to 1/2 the difference of the big arc minus the small arc. Same for all of them. Okay? 1/2 the difference of the big arc minus the small arc. So, just picking one of these as an example, we'll go with the first one here. If the big arc, we'll say, is 110, our small arc, we'll say here, is 60. The measure of our angle, angle 1, is going to be half the difference of big arc minus small arc. So 110 minus 60, or half of 50, which equals 25. Okay? And now we have 10 minutes left over to go over homework questions from the second page. Isn't that nice?
Can we not do this? That's my fault.
You are free to leave at any time. I am not a prison warden. The lesson isn't over yet, for the record, but I'm not keeping you here on my laptop. Thank you. Okay, any questions on this stuff? You made it through the notes. Now we get to practice. Anything you got? Okay, what's one on the second page? Linnea, you looked very excited to do some together. So is there one? What?
The sixth one, like, how are you supposed to?
The sixth one?
Yeah.
Oh.
The first one with the tangent.
Right, the tangent.
Yeah.
So in order to do a tangent question, we're asked to find that angle measure there, which means we need to know the value of the big arc and the small arc. Okay, that 247, that's our big arc. That represents from the point P down to R there. That's a 247. What's going to be the measure of, whoop, put that in the wrong spot. I'm going to draw it. What's going to be the measure of our small arc? Gabby. And how'd you get 113? Yeah. No. Sometimes, I mean, it's yeah, don't say yeah, that's okay. It happens. So we know it has to be 113 because it's the rest of the circle. So now you can set up the equation. Measure of angle x, which is our angle 1, is half the difference of the big and the small, and you can get the values that way. Another one you'd like to talk about? You may use a calculator. Oh, like one of mine? Oh, can you catch? The last one? Is that what you said, Elise? You had your hand up?
No.
Oh.
Wait, actually, no, the second to last one.
Okay. Second to last one. Oh, this is fun. Okay. So this is a good algebraic one here. It's a secant situation, which is the same formula as the one we just did, tangent. The measure of angle 1 is equal to 1/2 the difference of the big minus the small. Sometimes it's helpful to write the formula first and then plug in what we know. We know the measure of angle 1, actually. It's 34 degrees. That's given to us. So 34 equals half the distance of the big minus the small. And here's where the algebra comes into play here. Our big arc is represented by the expression 3 minus 2. And when we subtract that small arc, we actually need to put it in parentheses. If you just put minus x plus 6, that means you're only subtracting x. You want to subtract the sum of x and 6. So your next step here would actually be to distribute that negative sign into minus x minus 6. Okay? It's kind of like on your 5-card challenges. If you are, I've seen this happen before, if you have a 3, a 5, and a 10, and you want to make a 2, some of you in your head will think, okay, I'm going to start with 10, and then I'm going to subtract 8 from that, which is 5 plus 3, so 10 minus 8 equals 2. Well, actually, what this says is 10 minus 5, which is 5, and then you add 3 to that, which is 8, not 2, right? To do this, to subtract 8, you're not going to add 5 and 3, you're going to subtract 5 and then subtract 3 more. That's kind of the same situation here, okay? So we have to just distribute that negative sign into our parentheses, and it gives us this. And from here, combine like terms. So 34 equals half. 3x minus x is 2x. Negative 2 minus 6 is negative 8. to get rid of our parentheses, we could either distribute the half into our parentheses, which would work because we have even numbers. We don't get any fractions there. Or we double both sides to undo it, and we get 68 equals 2x minus 8, and I think you can probably solve for x from there. Okay? Mackenzie, does that answer your question? Okay. Any others? Any others? Or are we ending 6 minutes earlier than promised?
Yeah. I think we are. Or we can do the last one.
Or we can do the last one. Okay. So the last one here, we kind of a combo platter. I see a tangent line, so I know we have that type 1 where we have a tangent and an angle. I see two chords in the circle, which is also type 2, right? Which is when we have an angle inside of a circle. So depending on which angle we're solving for, we might need to use multiple methods here. But starting with angle 1, angle 1 is part of that tangent line. And the formula for that is that angle is going to be half the measure of the arc that it creates. The arc that it creates is PQR. And that measure of PQR is 220. So half of that is going to give us 110. Angle 2 is the other part of that tangent line. Angle 2 goes from point P up to point R. So it will again be half the arc measure. The arc measure is 140, 60 plus 80. Half of that is 70. So angle 2 is going to be 70. And this makes perfect sense because angles 1 and 2 create a linear pair. They make a line. And they add to be 180. 110 plus 70. So it all fits. Angle 3, part of those two chords that intersect, for this one, we want to look at the arcs that angle 3, which is QR, and its vertical angle, which is PS, create. Okay? And so the measure of angle 3 is going to be half the sum of those two arcs. 100 plus 60. Half of 160 is 80. And so angle 3 equals 80 degrees. Okay? All right. The only other one I want to talk about, because we had a tizzy of a discussion in the Monday group, is the one in the middle. Notice it's a chord situation, so you'll be using that type 2 formula to find it. But as it turns out, the angle we're given is not part of the arcs that it creates, right? We actually need to know what this angle is here to use the arc of 30 and the arc of 2x minus 30. So if the angle that we're given there is x degrees, what's the measure of that angle? The angle we actually need to use our type 2 equation. Linnea.
Half of 2x minus 30.
Well, it's going to be half the sum of 2x minus 30 plus 30.
Are you looking for the answer?
How can we write that as an expression? Because we don't know what half the sum of this is if we don't know what x is. Right? So if the given angle there is marked x, what's the measure of the angle adjacent to it? That happens to make a straight line with angle x. So we know that angle x and the angle we want sum to be 180. Gabby? 180 minus x. Right? Whoops, not 180x. So whatever x is, subtract that from 180, and we'll get the angle that we actually want. So your formula for this, 180 minus x is equal to 1/2 the sum of 2x minus 30, the angle it creates, or the arc it creates, plus the arc its vertical angle creates, which is 30, and you can solve for x. Okay? All right. It's 2:30. I made a promise. I'm a man of my word. If you'd like to stay and go over more, you may. Otherwise, we'll end the video, and you are free to carry on your Wednesday afternoon. So, questions, comments, concerns, complaints, comments, congratulations, or criticisms on your last live geometry lesson. All right, folks, that's how you math.